Welcome back to my YouTube channel. I'm Rishi, and today we are covering Form 5 Chapter 1 Variation. Without any further ado, let's get right into the video. So firstly, I have made a mind map here so that you can get an overall understanding of what we will be covering in this chapter. So we have three main parts, namely the symbol, the forms, and also the variation concepts. So these subtopics will be covered in two parts, in two videos. So I will be separating them into part 1 and part 2. And in this part, we will be covering the symbols, the forms, and two of the variation concepts. So I hope you're ready. And let's get started. So first things first, what is variation? It's important that we understand the definition of what is variation before we start dealing with the calculations part. So variation is simply put the relationship between two different quantities. The relationship as in, take for example, we have A and B. So when we have A and B, the relationship of both of them are connected in a way. It's either when A increases, B also increases, or the other scenario is when A increases, B decreases. So this is the concept of variation. Let me put that in perspective. For example, your mom is baking a cake. So let's assume that for one cake, to bake one cake, you would need 1 pack of flour and 3 eggs. Please forgive me if this quantity seems outrageous, because I personally have no idea on how to make or bake a cake. So this is just an example, so those avid bakers, I'm sorry. So this scenario is where your mom needs 1 pack flour and 3 eggs to bake 1 cake. So in this case scenario, if we are to bake 2 cakes, where we will need 2 pack of flour, logically you would say that we need 6 eggs, because 1 pack of flour needs 3, so 2 definitely will need 6. So what we did here is we multiplied by 2 and multiplied by 2. This logical standpoint is what we refer to as variation mathematically. This is what variation is. How is one quantity is related to another quantity in terms of a ratio, or we call it a constant in this chapter. So this is what we mathematically call as direct variation. No worries, we will cover all 4 types of variations. We will cover them as we go along the video. But right now, it's important for you to understand that this is what variation is all about. It's the relationship between 2 different quantities, where when one increases, another decreases, or where one increases as well as the other also increases. These are the 2 scenarios that are possible. And of course, we will have different variety where there's something called combined variation, where both of these things will meddle together, or should I say will mix together. Pardon my phone. Alright, so let's start off. So now that you have the understanding of what variation is, let's take a look one by one. Let's take a look at the little nuances one by one. So for variation, first things first, the symbol. The symbol that we have is this symbol, the one that looks like a fish. It does look like a fish, doesn't it? Like the fish we used to draw when we are primary school. So obviously from my drawing, you know that I'm no artist. Okay, that's just for reference. So this particular symbol is known as the proportional symbol. So proportional means it directly varies, or in other words, it means that when this increase, this also increase. So to put that in perspective, if I say A is this proportional symbol to B, this means that when A increase, B also increases. That's it. This is the definition of this symbol. It just says that whatever that is on the left hand side is whatever that's on the left hand side, if it increases, the one on the right will also follow suit. It will also increase. That's the definition of this proportional symbol and how this works. This is very important for this chapter, as you will be required to use this particular symbol to answer your questions. So now that that's done, it's time to take a look at the forms that we have. These forms are particularly important to understand when you're asked to state a particular situation or a particular question in this manner. So for forms, we have two. Firstly, we have the variation form. Don't worry, it's not it's just a fancy word. It's not that difficult. Variation form just means that you will have to use this symbol. This symbol has to be used in that expression. So, for example, the question says, as the value of x increases, the value of y also increases. So when the x increases, y also increases. So for that scenario, we can just write it down as x proportional symbol to y. That's it. So this denotes that when x increases, y also increases. That's the variation form. So the exact variation, the same situation variation form, can be written down as another form, which is equation form. Pardon my green color. Let me change it to blue. Let me change it to blue right here. It's the same color? Nope. There we go. So equation form. So don't worry, it's just that I am not a big fan of green. I don't hate green color, it's just that not a big fan. So equation form is when we will be using the equal symbol. This might get a bit confusing if I keep on using this symbol here. Let me change it to this. Alright. So equation form is when we use the symbol equal, because the word has the word equation, equal. So what you do is we take the exact same situation. So this symbol will be replaced with equals k. That's all you have to remember. It will be replaced with equals k. Then we just put down x as per usual and y as per usual. So this k, don't worry about it right now. I will be explaining to you about this entire k concept and the concept of constant in the next video, the part 2 video. In this video, I'm just going to introduce you to the basics so that you know how to work with the fundamentals. So k will be the constant. So x will be x and y will be y. So these are the forms: variation and equation. So let's take a look at the first type of variation that we have, which is direct variation. So direct variation is what we have been discussing since the beginning. When 1 increases, when a increases, B also increases. So this is the fundamental concept of direct variation. So if you were to write this, it's in an equation form, which is A equals to KB. This form is important to do calculations. That's why we learn this equation form, because most of the questions will be using this particular form of variation. So how your questions should be structured is in this manner. Let me give you an example. So let's take it as m equals to 0.8 and n equals to 0.25. It's given that m varies directly as n. So as I said earlier, varies directly is the same meaning as proportional to, which means just have to put the symbol. So since we already know the concept, we know the form, so let's first write it down in the variation form, where it will be m is directly proportional to n. It varies directly. M is varies directly to n. That's it. And then let's write it down in the form of equation. M equals to k. Remember, this becomes k, then n right over here. So for this scenario, what we have to do is we have to find this k. Don't worry about the definition of k for now. I'll be explaining it to you in the next video, but for now, just bear with me. Just treat k as any other constant. So we have this m. So m is 0.8. We just substitute it. So it becomes 0.8 equals to k, and n is 0.125. Now that we have all the values except for k, we can find k by moving this to the other side. Here it's times, that it will become divide. 0.8 divided by 0.125, and we get 6.4. That's about it. So k is 6.4. So all of your questions, most of your questions will be structured in this way. And then what they will do is, once you get k, they will give you a different value of m. For example, m is equals to 1. So they will ask you, when m is 1, what is the value of n? So when you're given this scenario, what you have to do is the exact same thing. Just write it down. Just write down the equation form, which is m equals to kn. Now that you know the value of k, you can easily substitute k as 6.4 and m as 1 equals to n. So n is equals to 1 over 6.4. 1 over 6.4. Let me get my calculator. 1 divided by 6.4, you will get 0.15625. That's it. So this is how a regular question in variation chapter looks like. So this is direct variation. No worries. I'm just introducing you to the basics and the fundamental ideas of this chapter. The next chapter we will delve deeper into the rest of the variation concepts, and I will be showing a bunch of questions so that you have an understanding of what to do. In relation to this, there's also another concept of joint variation. Don't worry, joint variation looks like it's going to be a lot of things. Nah, it's not. Joint variation is just, instead of A increase, B increase, we have when A increase, B increase is direct variation. But for joint variation is when A increase, B increases, and at the same time C also increase and D also increase. So when we have more than one value that's increasing in proportion to A, we call this a joint variation. Like it's joint, that are more than one. So the same concept goes for this as well. So we can consider it, if you want to write this in variation form, it will be A it varies directly to B times C times D. That's it. If you would write it in equation form, it will be A equals to K, B, C, D. Everything else follows exactly as direct variation. So I hope you understood the gist of this concept. You don't have to understand everything at this point. Just have a basic idea. In the next video, I will be going in depth on the next two variation forms, in the inverse variation and combined variation. Once we are done with that, we will be going through a few difficult variation questions so that I can teach you how to tackle those questions. By knowing how to tackle the difficult ones, the easy ones will be much more, it will be very easy to handle the easier ones. I've used the word easy too many times in that one sentence. Pardon me. Alright, so that's all for this video, and I hope to see you in the next one. Till then, bye bye.